Development teams are stuck between two impossible choices. Either hand over control completely to the AI and hope that it doesn't go off the rails, or micromanage every single line of code that AI generates, which defeats the entire purpose of using AI in the first place. AI-managed approaches sacrifice the strategic control you need, while AI-assisted approaches slow you down so much that you might as well be coding everything yourself. What if there's a third way? A systematic methodology that gives AI the autonomy to execute efficiently while keeping humans firmly in control of the strategic decisions. My name is Derick Chen, and this is BuildWithDC. Hi, I'm Derick Chen. I lead the AWS AI-Driven Development Lifecycle program across 7 APJ countries, which I built and scaled from the ground up. Working directly with customers across industries, I've helped teams achieve 5 to 20 times faster development velocity by reimagining the software development lifecycle. I share these results on the AWS reInvent stage. And in this series, I'll break down exactly how they were achieved, the trade-offs, and how you can start applying them in your very own organization. Before we dive into AIDLC, let's talk about why traditional software development practices don't work well with AI. Think about how most teams operate today. You spend weeks in planning meetings, creating detailed specifications and mapping out architectures. And then you spend months executing that plan, only to discover halfway that something fundamental needs to change. Whether you're using Waterfall or Scrum, these methodologies were designed for humans working together only. Waterfall can enforce robust design. You plan everything upfront and hope that nothing changes. Scrum gives you flexibility, but comes with significant ceremonial overhead, especially in the age of AI. Daily stand-ups, sprint planning, retrospectives, backlog grooming. Neither approach was designed natively to leverage AI capabilities. They don't account for AI's ability to rapidly generate code and documents, analyze requirements, or suggest architectural patterns. And they definitely don't address the collaboration dilemma we just talked about. And this is where AIDLC fundamentally differs. AI-Driven Development Lifecycle, short for AIDLC, reimagines the traditional SDLC into just 3 phases: Inception, Construction, and Operation. But here's the key insight. Each phase uses incremental complexity decomposition to reduce the ambiguity for AI at every step. So instead of carefully crafting a long prompt or creating a massive specification document that AI might misinterpret, you build context incrementally. Each step produces artifacts that become the foundation of the next step. The trade-off decisions you make are completely captured in the artifacts and the codebase, and are then used as reference for what comes next. This incremental approach means AI always has the right amount of context. Not too little, not too much, just to execute effectively while human maintains strategic control at important checkpoints. We will first start with the phases and steps of AIDLC, then I will share more on how we tactically interact with AI to find the right balance between autonomy and human in the loop. So let's start with phase 1, Inception. The objectives here are simple but critical. Establish the business context of your problem space and identify behavioral requirements as the foundation for your technical solution. This is where teams collaborate with AI to transform customer requirements into detailed user stories, acceptance criteria, and business specifications. And here's how it works in practice. You start from a business intention or a customer pain point. Let's say the customers need to browse and purchase products online. You and your team then work with AI to elaborate this into comprehensive product requirements that might be in the form of user stories or PRDs. The AI doesn't just write user stories for you. It provides comprehensive analysis of the business intent. It asks clarifying questions. Should the customers be able to save items to a wish list? Do you need inventory management? What about guest checkout versus user accounts? The AI identifies potential challenges and blind spots early. It might flag something like, if you want real-time inventory updates, you might consider how to handle concurrent purchases of the last item in stock. These are some of the real challenges we've faced before. The output from this step is a set of product requirements, user stories, acceptance criteria, and potential test plans that everyone, human and AI, can work from. And now you have the detailed product requirements. The next step is grouping them into actionable work units. These units are the potential software system boundaries, following the principles of high cohesion and loose coupling. And this is where AI really shines. It helps break down those user stories into work units that can be built and run by a single cohesive team, and multiple teams can build in parallel. Not massive epics that take months, not tiny tasks that lose context, right-sized units of work. We often also create a draft integration plan. The different units could be implemented as a module in a monolith or a microservice later. I'll share more about the new team structure and various roles in a future video. AI also suggests optimal development sequences. It might say, build the product catalog first, then the shopping cart functionality, and then the checkout process, because each builds on the previous one. It creates implementation roadmaps with effort estimations based on the complexity it sees in your requirements. The output is a clear implementation roadmap with well-defined boundaries. Everyone knows what needs to be built, in what order, and roughly how long it should take. Here's the key insight for Inception. The business context you establish here becomes the foundation for every technical decisions that follows. You're not just writing requirements. You're building the shared understanding that both humans and AI will reference throughout development. And phase 2 is construction. The objective is to transform these business requirements into working technical solutions. This happens through 4 distinct steps, and each building on the previous one. First, you apply domain-driven design principles to create conceptual models that capture your business logic and domain boundaries. If your team is not familiar with the particular philosophies of DDD, you can choose another design system. You work with AI to identify entities, the core objects in your system, value objects, things that are defined by their attributes rather than identity, and aggregates, cluster of related objects that should be treated as a single unit. For our e-commerce example, AI might help you identify product as an entity, price as a value object, and shopping cart as an aggregate that contains multiple cart items. The output is a clear understanding of your business logic and where business logics are planned for implementation. At this stage, we do not make any technological decisions at all. Now in step 2, this is where you transform those conceptual models into logical architectures. You're defining system components, interfaces, and integration patterns. AI suggests architectural decisions based on your conceptual model. It might recommend, based on your inventory management requirements, consider using an event-driven architecture so the inventory service can update product availability in real time across all channels. The output is a complete system architecture with AI-suggested decisions that you have validated and approved. You do need to take time to carefully evaluate the trade-offs, clarify with AI the pros and cons. At this stage, we will choose what kind of compute platforms we will have, what kind of databases, and how do we structure the data schema. And finally, in step 3, we generate source code and tests. This is where the magic happens. AI generates implementation code based on this conceptual design and the logical model scaffoldings that you have just created with AI's help. But here's what's different from just prompting an AI to write me an e-commerce site. The AI has all the context from Inception and earlier construction steps. It knows your business requirements, your domain model, and your architectural decisions. Humans focus on the strategic decisions and quality validation. You are not reviewing every line of code. You are ensuring the implementation aligns with a strategic intent. AI also generates automated tests based on your acceptance criteria from the inception phase. The output is working code with comprehensive business logic test coverage. And finally, in step 4, we implement infrastructure as code for deployment automation. AI helps you create IAC templates, whether that's CloudFormation, Terraform, or CDK, or whatever you're using. It sets up comprehensive testing in non-production environments based on your logical design and source code implementations. You validate that everything works before it ever touches production. The output is a deployment-ready system with validated infrastructure. The most important thing for construction is that this is a progressive refinement in action. You start with abstract concepts and gradually refine them into working systems. At each step, AI has the exact context it needs to execute effectively, and humans maintain control over strategic decisions. And now we come to Phase 3. Phase 3 is operation. The objective is to integrate your solution with your production infrastructure, with a focus on observability and self-healing capabilities. You execute production deployments using these validated IIC templates from the construction phase. AI assists with monitoring setup and rollback capabilities. If something goes wrong during the deployment, AI can help you roll back quickly using the same IIC templates. The output is a live system with operational monitoring in place from day one. Now, incident management is where AI becomes your operational partner. It assists with incident detection, spotting anomalies in your distributor metrics and logs. It helps with analysis, correlating events to identify root causes, and it assists with resolution, suggesting fixes based on those similar incidents before. But human maintains oversight of critical system operations and strategic responses. You are not letting AI automatically restart production services or landing PRs without approval. You're using AI to accelerate your incident response while keeping humans in control of critical decisions. The output is a self-healing system with strategic human oversight. Operations isn't separate from development anymore in the you build, you run model. It's an extension of the same methodology. Now let's talk about the universal collaboration pattern that runs through every single step we just discussed, the plan, execute, validate cycle. In every step, teams collaborate with AI to elaborate each step's objectives into detailed specifications and implementation plan. AI works as a partner. It asks clarification questions to gather more guidance and more specific context from you. It provides comprehensive analysis, suggests optimal approaches, and identifies potential challenges before execution in each step even begins. This is your first human-in-the-loop verification point. You catch problems early when they are cheap to fix, rather than discovering them later when AI has generated thousands of lines of code. This is a technique that can significantly reduce human review fatigue. The value here is early course correction. You minimize those painful full-scope reviews where you have to tell AI this is completely wrong and start over from scratch. For execution, AI handles the routine implementation tasks according to the approved plan, and you will focus on the strategic trade-offs, decisions, and quality validation. This partnership is the core of AIDLC. You are not micromanaging every line of code. You are not giving up control at all. You are maintaining oversight while leveraging AI's capability for rapid, consistent implementation. The value is speed without sacrificing control. And in validation, we continuously review, verify, and create feedback loops to ensure the quality throughout development, not just at the end. By validating the artifacts created in each iteration, in each step, fulfill all business and technical requirements, you minimize the risk of small mistakes or context gaps escalating into larger, inaccurate implementations that are more difficult to review and expensive to correct. Would you rather catch a misunderstanding about your domain model during conceptual modeling, or after AI has already generated an entire code base based on that misunderstanding? The value is that incremental validation is dramatically cheaper than end-stage correction. This plan, execute, validate cycle is what makes AIDLC work. It's a mechanism that balances AI autonomy with human control at every step. Let's bring all of this together. What does AIDLC actually gives you? Speed. You move away from traditional lengthy planning phases followed by months of execution to rapid iterative cycles that doesn't last more than 2 or 3 days. You are building and validating continuously, not in big batches, not in 2 to 3 weeks. Most build cycles, or what we call bolts, in AIDLC, take no more than 2 to 3 days compared to the traditional 2-week sprints. Continuous validation throughout development means that you catch problems early on when they are cheap to fix, not at the end when they are expensive. And control. You maintain the strategic human oversight without micromanaging every detail. AI handles the routine work and you handle the strategic decisions. Scalability. This is a systematic approach, not an ad hoc AI usage. You can onboard new team members easily into this methodology by relying on existing contexts of your projects. You can apply it consistently across different projects. For more complex systems, you can also have multiple teams built in parallel. AIDLC transforms the development cycle itself. You're not just using AI as a faster way to do the same old process, you are fundamentally changing how development works. This is the future of software development. So here's what you need to remember. AIDLC gives you a balanced methodology with 3 phases: Inception, Construction, and Operation. Each phase contains specific steps that build context incrementally, and each step follows the plan, execute, validate cycle to maintain quality while moving fast. Understanding the methodology is just the first step. The real question is, how do you actually implement this with your team? What does the team structure look like? And what are some specific practices and ceremonies we will follow? And that's exactly what we'll cover in the next video, where I will introduce you to the concepts of taxi teams and the mob ceremony approach that makes AIDLC work in practice. Thanks for watching. If you like my content, remember to subscribe to the channel. My name is Derick Chen, and this is BuildWithDC.